everyone, this is Miss Lindblad from Beach High School. I teach 9th grade math. Today we're going to be talking about solving multi-step equations. Our standard is on the screen. Today we're going to focus on identifying and defining the key parts of an equation, and we're going to learn how to solve multi-step equations in one variable. Our expectations, much like they are in my classroom, I want you to follow along, and if you need to, take some notes. They'll be helpful for you later on when you come back and visit this lesson. Also, try the examples. Don't be afraid to get in there and practice, because practice makes perfect. One of the most important things, if you get stuck, don't give up. Keep trying, because you can come to the right answer just by persevering. And last but not least, if you need help, ask somebody. You can ask your teacher. You can reach out to any math teacher in the district if you need help. Some things you'll need when you get started on this lesson, just basic things you have around you. You'll need some paper. You'll need a pencil or a writing utensil. We like to use pencils in math in case we make a mistake. And you can have a calculator if you need to. So to start off, we're going to talk about some keywords and terms that we use to describe equations and some parts of the equation. So it's very important to learn your vocabulary because it helps you to describe your process, and it also lets you use that precision when you go to explain something. So a few things we're going to talk about. In this sample problem on your screen, we have our coefficients, we have variables, we have constants. Of course, the equal sign signifies that it's an equation, and we have terms. So our coefficient, in this case, is 3. Our coefficient is going to be the number in front of the variable. It is attached by multiplication. So the 3 is multiplied times the variable, and that is called our coefficient. Our variable is the unknown in the equation. It's often represented by a letter. It can be X. A lot of times it is X. It doesn't have to be. It could be A, B, any letter in the alphabet. So together, the coefficient and the variable make up a term in your equation. In this example, 4 and 12 are our constants. Constants are numbers that do not change, much like the definition of the word constant. It doesn't change, it stays the same. So those values are for numbers that will never change. Variables do change, so one problem, x may be 2, another problem, x may be 12. But in this case, constants never change, so they are just the number. Let's get into the meat of the multi-step equations. So there are 3 basic rules for solving them. The first one, I like to call this our main goal of solving equations. And when you solve an equation, you want the variable by itself on one side. So you want it to be alone. You want to isolate the variable is a lot of what a lot of people call. So in this equation, down low, 3x plus 4 equals 12. You have x equals some number. So when you solve it, you want to end up with x on one side of the equal sign and the number, the value that you get to represent x, on the other. That's called isolating the variable. The second rule for solving multi-step equations, and this is important in the process of how you solve it, you need to use inverse operations. So what do I mean when I say inverse operations? Inverse is the opposite. So I listed them for you in case you forgot. Inverse operations, the opposite of addition is subtraction. The opposite of subtraction is addition. So it's the opposite of what you would normally have. So in order to do that, if you have an addition in the equation, you're going to want to subtract to get rid of that and cancel that value out. And you'll see that in just a second when we do some examples. The third rule, and I like to call this the golden rule of solving multi-step equations is whenever you do to one side of the equation, you have to do it to the other side. You have to keep it balanced. And what I like to tell my students, I like to give them a visual. I'm a visual thinker, so I like to explain it with pictures. So think of a guy lifting weights. In the goal of lifting weights, you want the same weight on both sides of the barbell. What would happen if you have a weight on one side that was more than the weight on the other side? Do you think he would be able to stand up and keep his balance very long? Probably not. He would be weighted to one side and he would probably lose his balance and fall over. So it's important when we solve multi-step equations to keep them balanced at all times. Let's start off with an example. And you can pause this and write this example down, and then when you're ready, you can follow along and we can go back through it together. To start off, we're going to look at this problem, and the first thing we're going to solve this problem, the first thing we're going to do is to look and see what our variable is and how are we going to get it by itself. So if you notice, I have the problem listed at the top, 3x plus 5 equals 17. And at the very bottom, I have x equals, and then I left it blank. I did that to remind us that x needs to be by itself when we solve. So in order to do that, we have to go to rule number 2. We have to use inverse operations. So the first thing we want to look at is we want to look at that plus 5. Because the variable is attached to a coefficient, we want to get rid of everything that's not part of that term. So the plus 5 in that instance on the left side of the equation needs to be gone first. So we need to cancel out that term first. The opposite or the inverse operation of addition is subtraction. So that means we subtract 5 from both sides. When we do that, the positive 5 and the negative 5 will cancel out. They become 0. It leaves you with 3x on the left side and 12 on the right side. From this step, now we're left with one term on the left and one term on the right. How do we get the x by itself? Well, remember what we said. The coefficient is attached to the variable through multiplication. So the 3x is actually 3 times x. So in this case, we're going to do the opposite or the inverse operation of multiplication, and we're going to divide both sides by that coefficient, which is 3. So when we divide both sides by 3, we're going to get 3 divided by 3 is 1, so you get 1x. And typically, we don't write the 1 in front of the x. It's understood. You can write it if you want to, but we just understood that it's a 1 as a coefficient. And then on the right-hand side, you get 12 divided by 3, which is 4. And your solution would be x equals 4. Here's another example, and I encourage you at any time, if you want to pause these videos, to pause it, write it down. Maybe you want to try it for yourself and then come back and see if we got the same answer. So in this case, we have negative 3x minus 4 equals negative 82. So much like the last problem, we have our x as our variable, and we need to get x by itself. So I've listed x equals at the bottom as a reminder. One thing I want to point out, it's much easier to solve these if you line your equal signs up all the way down so that you can keep track of what is on the left side and what is on the right side. And when I say the left side and the right side, I mean of that equal sign. That equal sign is our barrier. So in this case, we have a negative 3 attached to the x, that's one term, and then we have minus 4 on the left side. So our first step is to get rid of that negative 4, or that minus 4 on the left side. So the opposite of subtraction, the inverse operation, would be addition. So we're going to add 4 to both sides. When we add 4 to both sides, our left side gives us negative 3x, because the negative 4 and the positive 4 cancel out. And on the right side, we get negative 82 plus 4, which is a negative 78. Much like the last problem, we have negative 3x equals negative 78. That negative 3 is our coefficient, and the x is our variable, so we need that variable by itself. The coefficient is attached to the variable through multiplication, so we're going to do the opposite or the inverse operation, and we're going to divide both sides by negative 3. Keep in mind that what we're doing to one side, we're doing to the other side in every step of the equation. So when we divide by negative 3, we get negative 3 divided by negative 3, which is 1. So we're left with 1x on the left side, and we're left with 26 on the right side. So our solution is x equals 26. This is also a reminder that when we have integers, such as negative and a negative divided by a negative is a positive. So keep in mind, a lot of times we get tripped up by the sign. Keep in mind those integer rules when we are adding and subtracting negative numbers or multiplying and dividing negative numbers. Keep those rules in mind. All right, before we practice, I want to do one more example with you, and we're going to come to the document camera. And this one's a little bit trickier. And so what we're going to do is I have this problem. 30 equals negative 5 times the quantity of 6n plus 6. So our first step here, and we haven't talked about this before, but we have this negative 5, and it's multiplied by everything in parentheses. So we have to use the property of the distributive property. I like to show this by drawing some arrows. That helps me to remember to multiply this outside number by everything on the inside. So I'm gonna draw a faint line down the middle here so you can see that we're lining it up. We keep everything on the right side the same, so I bring the 30 down. Negative 5 times 6n, so multiply the numbers. Negative 5 times 6 is negative 30, and we keep that variable. And on this side, we have negative 5 times positive 6, which is a negative 30. So you can write plus a negative 30, or you can just write minus 30. It's the same thing. So in this case, I wrote minus 30. Now, this kind of looks like the same setup that we had with our previous examples. In this case, we have our variable here, and we want to get that by itself. So we're going to end up with n equals some number. In this case, we need to get rid of the 30. So the opposite of subtraction would be addition. Remember rule number 3, whatever I do to one side, I have to do to the other. So I'm going to add 30 on both sides. And when I do these by hand, I like to draw a little line to keep me organized. So negative 30 and positive 30 are going to cancel, so I just mark through those. We're going to put an equal sign here. Bring this term down, so we have negative 30n. And on this side, we have 30 plus 30, which is 60. So we have 60 equals negative 30n. Once again, we need the n by itself, so it's attached. The n, the variable, is attached to the coefficient through multiplication. The opposite, or the inverse operation of multiplication, is division, so we're going to draw our dividing line. And we're going to divide both sides by that coefficient, which is negative 30. Negative 30 divided by negative 30, that makes 1. So we're left with n on the right side. 60 divided by negative 30 gives me negative 2 on the left side. So our solution would be n equals negative 2. Now, the neat thing about multi-step equations and equations in general is that you can always find out immediately if you have the right answer or not. You can go back and check your work. How do you do that? Well, You take the original problem we have, which in this case, let me pull it down, 30 equals negative 5 times the quantity of 6m plus 6. So we take this original equation, I rewrote it here, but you'll notice one thing. I left out our variable. Why would I leave out our variable? Because in order to check our answer, we're going to substitute our solution back into the original equation. So here, I'm going to say negative 2. So we're going to do order of operations. So we'll say 30 equals negative 5 times 6 times negative 2 is negative 12. And then we'll do plus 6. Parentheses comes next. So we have negative 12 plus 6 is a negative 6. So we're left with 30 equals negative 5 times negative 6. And a negative 5 times a negative 6 equals 30. So we're left with 30 equals 30. If this solution is true, which we know 30 does equal 30, we have got the correct solution. If you get an answer, let's say it's 30 equals 25. So go back and double check your math here. And if you didn't make a mistake here, then you need to revisit your original problem up top and see where you may have went wrong. Okay? That's the beauty of these equations, is that you can automatically tell if you've got the right answer or not. So in this case, we know that n equals negative 2 is the right solution. Now it's your turn. Let's practice some. I'm going to give you a few minutes. I want you to copy these problems down on your paper. Use these examples that we've done, all 3 of them, as a guide. Number 4 is a little bit of a challenge, but I think you can do it. And I want to encourage you to practice. Practice, 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 because you can never do these enough. This is a skill you're going to learn and you're going to need all through math. It's a foundational skill. So once you learn how to solve equations and can do them with your eyes closed, then you're going to be a scholar when it comes to math. So I encourage you to pause the video, copy these problems down, and practice them. If you get stuck, remember to keep going. Go back and check your answers. That's a great way to see if you've got the problem right. And if you're really stuck and have no clue where you went wrong, then ask for help. Don't be afraid to ask for help. That's all I have for you today. I thank you so much for your time and attention, and we look forward to seeing all the great things that you do in math in the future.